So this question asks us to find the scalar equation of the plane contained with the line of intersection of the planes defined by the two equations that they give us here and the point 1, 0, negative 2. Okay, so you're not asked to do anything in this question that you haven't done before. They've just put a bunch of different things together into one question. So what we're going to do first is we're going to find the line of intersection of these two planes. And then we'll have the equation of a line and we'll have a point. And then we'll find the equation of the plane that is defined by that line and that point. Okay, you've done both of these things separately before. We just have to do them all together. So it's kind of a long question and there's a lot of places where we can go wrong, but it should be nothing you haven't seen before. So equation of the line of intersection here, what we're going to do first is we are going to eliminate a variable from these two equations that we've got here. So the easiest thing to eliminate is going to be z, because I just have to add them. So that's first step, eliminate z here. So if I add those two equations together, because I've got a plus z and a minus z, that'll eliminate the z's, I get 3x minus y, the z's cancel, and then negative 2 plus 5 is plus 3 equals 0. Okay, that's one of the equations I'm going to work with, and then I've got to eliminate another variable between these two. I think the next easiest is to eliminate x. So to do that, I'm going to keep the first equation exactly the same. And then I'm going to multiply the second equation by 2, so it's going to become 2x plus 4y minus 2z plus 10 equals 0. And then I need to subtract these two equations. So the x's cancel. Negative 3 minus 4 is negative 7y. Z plus 2z is going to be positive 3z. And then negative 2 minus 10 is negative 12 equals 0. So I've got an expression involving x and y, an expression involving z and y. So I am going to choose y to be my parameter. Okay, so I've got to rearrange each of these to get them in terms of y. So this x equation is going to become, let's see, 3x equals negative 3 plus y, or x equals negative 3 divided by 3 is negative 1 plus 1/3 y. And then over here with my other equation, I am rearranging this for z, so I'll have 3z is equal to 12 plus 7y, or z is equal to, that gives us 4 plus 7 over 3y. Now, I don't like those fractions in there, so what I'm going to do is I am going to let y equal 3t, because then when I sub 3t in for y, that's going to cancel out the fractions that I have. So my parametric equation here for my line of intersection is going to be negative 1 plus 1/3 times a third times 3. It just gives me 1, so plus t. The y equation is, of course, 0 plus 3t. And then my z equation is going to be 4 plus, subbing in the 3t, cancels with the 3, so just 7t. Okay, so we've got the line of intersection. So in this line of intersection, we now have a point, negative 1, 0, 4, and we have a direction vector, which is 1, 3, 7. And we are given another point, I'll call that P1, I guess, because we were given this other point in the plane. Originally, we'll call that P2, which is 1, 0, negative 2. So now I have a vector, and I have 2 points, and I want to use them to define a plane. So let's slide all this stuff up here and go to work. We've got one direction vector, 1, 3, 7. We need a second direction vector. We'll call that D2, and we're going to get that by subtracting the coordinates of our 2 points here. So I'm going to do 1, 0, negative 2 minus negative 1, 0, 4. Doesn't matter what order I subtract these 2 points in. That's going to give me a direction vector of 2, 0, negative 6. And instead of that, I'm going to divide everything by 2, and I'm going to use 1, 0, negative 3, just so the numbers are a little smaller. Now, I've got 2 direction vectors, and I got 2 points that are on my plane. I want the scalar equation of the plane, so I don't want the direction vectors. I want the normal vector, which we have to do by doing the cross product of these two things. And when I do the cross product, I am going to get negative 9, 10, negative 3. Okay, did that on another piece of paper over there. And now that I've got my normal vector, I can figure out my scalar equation. So I've got negative 9 times x plus 10 times y minus 3 times z plus d equals 0. I'm going to sub in my point here, which is, doesn't matter which point I use, so I'm going to use negative 1, 0, 4. And that gives me 9 minus 12, which is going to be negative 3 plus d equals 0, so d equals 3. So my scalar equation is going to be negative 9x plus 10y minus 3z plus 3 equals 0.